So now we are going to start looking a little more in depth at these graphs of sine and cosine equations, okay? So hopefully we remember that this is what, what's up with my thing here again? As soon as I start a video, it always goofs. This is what the sine graph looks like, okay? One period technically goes from here to here, okay? Because the graph doesn't stop, it continues to the right. It also continues back to the left. Now the period, okay, also you'll hopefully notice that the x-axis is labeled in radians. Now the period, okay, how long does it take for the graph to repeat? So it starts at 0, okay, and it goes to 2 pi. So if we're dealing with degrees, the period is 360 degrees, but we're almost always going to graph in radians, so our period is 2 pi. Okay, now amplitude, okay, what is the amplitude? This is basically the distance from the max to the axis of the wave. Now, the axis of the wave is the middle of your wave, okay? So in this case, the axis of the wave is just the x-axis, right smack here in the middle. But as we do with all graphs that you've ever dealt with, we will start shifting things. So the axis of the wave will move up or down. So now, how far is it? Well, the max is 1. So in this case, it's just 1 minus 0, which gives us an amplitude of 1. Now, because it's a distance, okay, amplitude is always a positive number. Okay, now what is the range? Range deals with the y values, okay? So the y values of this, the lowest this graph goes to -1, the highest this graph goes is +1. So you could say from -1 to 1 this way, or in interval notation, which some of you understand, is from -1 to 1. -1 is the lowest it goes, +1 is the highest it goes. Brackets because it includes reaching -1 and 1. Now, I didn't ask this question on the sheet, but hopefully we should know the domain, okay, that's your x values, okay, is in interval notation, it's -infinity to infinity, or it's all real numbers, okay? It continues to go infinitely to the left or to the right. Now, when you have to graph these by hand, the key points that we want are listed right here, okay? There are max values and our min values and the points right on the axis, okay? So it starts at 0, 0, which is the middle. Sine graph will always start in the middle, okay? At a half pi, it's 1. At pi, it's back to 0. At 1.5 pi, or 3 pi over 2, it is -1. And at 2 pi, it is back to 0. Starts and finishes in the same place, okay? Hopefully pretty straightforward. These are the points that we want to graph, maxes, mins, and the intercepts. Notice we have 5. There's always going to be 5 points per period that we have to graph, okay? So now, going to the next one. All right, let's look at cosine. So I have the cosine graphs over here. Hopefully remember that cosine looked something like this for one period. That's what you guys did last time, okay? Notice cosine starts at the top, okay, because the cosine of 0 is 1. Period is still 2 pi. Amplitude is still 1 minus 0, which would be 1. Range still -1 to 1. Or from, you can write it this way, but we're going to have to make sure we get comfortable with interval notation. Okay, because that's how we're going to do stuff. Key points, all right, are when x is 0, our y value is 1, our cosine value is 1. Okay, and at pi over 2, it's 0. At pi, it's -1. At 1.5 pi or 3 pi over 2, it's back to 0. And at 2 pi, it's +1 again. Okay, notice cosine starts at the top. All right, because the cosine of 0 is 1, because on the unit circle, right over here, cosine's our x value, it's the 0.10. Okay? Also, when you sketch by hand, you must include 5 points in each cycle. By cycle, I mean period. Okay, and it says the min, the max, and the intercepts. Okay? So now, let's look at what happens with some things here. Why won't this change? Okay, so now, I want us to graph y equals 2 sine x. What's going to happen with something like this? So if we think about this for a second, let's look at the unit circle again. Okay, 1, 0, 0, 1, -1, 0, and 0, -1. Okay, so when x is 0, if I plug 0 in, okay, now sine is our y value, it's still 0. because 2 times 0 is 0. But at pi over 2, the y value is 1. So the sine of pi over 2 is 1. And then I'm multiplying it by this 2 out front, which makes this 2. At pi, my y value is 0, so therefore the sine is 0. Sine of 0 is 0. 0 times 2 is still 0. 3 pi over 2, my y value is negative 1. Okay? And then 2 times negative 1 would give me negative 2. And then back at 2 pi, I'm back to it being 0. So what does this graph look like? Well, we still have 0, 0. At pi over 2, though, we're not going up to 1, we're going up to 2. Okay? At pi, we're back to 0. At 3 pi over 2, we're down to negative 2. And at 2 pi, we're back to 0. Now, the shape of the graph doesn't really change, but our labels on the y-axis have to. So the period is still 2 pi. But what actually happened? What changed? We didn't go up to 1 and down to negative 1. We went up to 2 and down to negative 2. So when this says, come on, what happened? There was a change in the amplitude. Okay? So now, any number you have out in front of sine or cosine will always affect the amplitude. Okay? Now it says amplitude is absolute value of A. Okay? Remember, amplitude is always positive distance. So some people look at it as it's always half the distance between the max and the min values. Okay? I like to look at it as it's the distance from the max or the min to the axis. Okay? If A is negative, the graph will reflect over the x-axis. Okay? Now, what does this mean? So let's graph 2 full periods of each of these. Be sure to label both of our axes. So our cosine graph, okay, if you remember, usually starts up at 1. If we go back to the cosine graph, it would normally start here, okay, and look something like this. Now, because for this one, I want to graph y equals 3 cosine x, instead of starting up at 1, it's going to start up at 3. Because my amplitude is going to be 3. All right, so now we're going to finish out at 2 pi. So that's pi. So this is pi over 2. Okay, this is 3 pi over 2. Okay, I didn't leave myself a lot of room here to graph 2 full periods, but I want you guys to graph a second one on your own. All right, cosine, I'll do it in purple. Starts up at 3. Okay? Now it goes to the axis. Now you're never going to skip over from max to min. You're always going to go by each interval. So then pi over 2 is 0. At pi, it's down at negative 3. At 3 pi over 2, it's back to 0. At 2 pi, it's back to 3. Now, if you wanted to, I ran out of room to the right. So nothing that says I can't graph a period to the left because you can have negative angles. So I'll do that. I'll go negative pi over 2. Negative pi, negative 3 pi over 2, negative 2 pi. Now what's going to happen when I graph back to the left? I'll do that part in green. So we're going backwards, right? So we're at negative pi over 2, at negative 90, your cosine value is still going to be 0. At negative pi, it's going to be negative 1, but times the 3, which makes it negative 3. At negative 3 pi over 2, it's back to 0. And at negative 2 pi, it's back up to 3. And there is my second period. When I play connect the dots, we'll see that we have 2 periods. Okay? Y equals negative 4 sine x. That's not much different. Okay, we're going up to 4 and down to negative 4. Okay, 1, 2, 3. 1, 2, 3. Now, we do have a negative here. And this says that if there's a negative, the graph reflects over the x-axis. What does that mean? Continue, forget that doesn't work. So if I go back to what my sine graph looks like, normally sine starts here at 0 and will go up. If it's reflecting, it's going to start at 0 and go down. So I'm going to start at 0. Okay, my intervals are pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to start by reflecting and going down. Okay, so we have our 5 points there, starting and finishing in the same place. Play connect the dots. Okay, you guys can graph a second period on your own to make sure you're comfortable with it. It'll go all the way out to 4 pi if you want, or it can go back to negative 2 pi in that direction. Okay, so number out in front affects our amplitude. Now we also have talk about the concept of a period. Okay, so period is how long it takes for something to repeat. Okay, how long it takes a graph to repeat, or if you want to look at it a little differently, to complete one cycle. Now, I'm going to use our graphing calculator for this to play around for a second. Okay, so I'm going to get rid of cosine x for a second. So I have y equals sine x. My window I have going from 0 to 2 pi, okay, which is perfectly fine. All right, and let's see what happens. So if I graph y equals sine x, that looks like this. I'm going to throw a second graph in there. I'm going to graph y equals sine of 2x. So the sine of 2x is in red. The sine of x is in blue. What happened? How many periods did we actually see now from 0 to 2 pi? So the blue one still has 1 period, but the red one now has 2 periods. And it goes from here to here and stops. That's 1 period right at pi. So the period is no longer 2 pi, the period is pi. Okay? What if I throw a 3 in there? Okay, and I graph it. Now I have 3 full periods between 0 and 2 pi. So what this means is the number that is in front, okay, which they put a b here, that number affects the period. Okay, that tells us how many actual periods we'll have between 0 and 2 pi. So as long as b is a positive real number, the period you get for an equation is 2 pi divided by b. Okay, now if I change this for something else also, all right, let's throw a half in there. That means that we're going to have, I hope, half a period. Let's check. The answer is, yep, we only get the top half of this graph. Okay, so if I were to change my period to 0 to 4 pi, we would get the bottom half of this graph coming along on the right-hand side. Okay, so b is the positive real number. The period is 2 pi divided by b. Now the interval, okay, of a period is your period divided by 4. What's nice about this is the interval along the x-axis. So this is what we're going to label the x-axis. Okay? So if we have y equals negative 3 cosine of x over 2. Now that's the same as me saying negative 3 cosine of 1/2 x. Okay? So this negative 3 affects the amplitude. So now our amplitude is 3. Our period is going to be 2 pi divided by that number in front of the x. 2 pi divided by a half. Now I hope we know that dividing by a half is like multiplying by the reciprocal. So our period is 4 pi. Now the interval that we label our x-axis, okay, is what your period is, which is 4 pi, always divided by 4. So our interval now is going to be pi instead of pi over 2. So now it's pi, 2 pi, 3 pi, 4 pi. Amplitude is 3, so we're going up to 3 and down to negative 3. And it's a cosine. So now cosine normally starts at the top. However, because we have this negative in front, we also have to reflect it. So instead of starting at the top, we're going to start at the bottom. So the cosine of 0 is still technically going to be, it's 1, and then times this negative 3 gives us negative 3. Then we're to the middle, then we go up to the top, back to the middle, back to the bottom. That's 1 period. Okay, you can graph another period either out to the right or back to the left. Okay, if you go out to the right, you would stop at 8 pi. If you go back to the left, you would stop at negative 4 pi. Okay, the shapes of the graph aren't changing. It's what our intervals are now along our axis. Okay, let's look at the next one. 3 sine pi over 4x. Okay, so again, our amplitude is 3. Okay, the period is 2 pi over 4. which is the same as saying 2 pi times 4 over pi. Pi's cancel, so it gives us a period of 8. Now this is still 8 radians, okay? And then the interval is what our period is, which is 8 over 4, which is still 2 radians, okay? We're always going to be graphing in radians. Now that makes this a little bit nicer to look at visually for us because it's just 2, 4, 6, and 8, okay? Amplitude is 3, so we're going up to 3, down to negative 3. Sine normally starts in the middle, okay, because the sine of 0 is 0. So it starts here, okay. Sine will go up. It's positive, so it's not reflected. So there, back to the middle, back to the minimum, back to the middle. And if you were to continue doing 2 periods, it would look something like this. This would be labeled as 16, okay, and it's going to look something like that. All right? Beautiful. Almost done here. Last one. So 4 sine 3 pi x. So our amplitude is 4. Period is 2 pi over 3 pi. Pi's cancel, so our period is 2/3, okay? The interval that we're going to label our x-axis is 2/3 divided by 4. Now, I'm going to put 4 over 1. Dividing by 4 is the same as multiplying by a quarter. So that gives us an interval of a sixth. Again, still radians. Not a big deal. Looks a little ugly, but this is 1/6. Now just count off by a sixth. This is 2/6, which I'll say is a third. This is 3/6, which is a half. This is 4/6, which is 2/3. That's what our period is. We should always be stopping at what our period is. Up to 4, because the amplitude is 4, down to negative 4. Okay, do this in a different color. Sine starts in the middle. It's positive, so it goes up. And it looks something like this, okay? And if you were to continue going on, okay, this is 4/6, then you'd have 5/6, 6/6 would be 1, 7/6 would be here, and then 8/6 would be 4/3. 4/3 is 2 of 2/3, so that would be your second period. Okay? Not shifting anything yet. That's what we're going to get to next time. But, all right, that's it. All right, people, how we doing here? Quick review. This is not on your note sheet packet, but pay attention to what we're doing here. Make sure what I'm doing makes sense. We need to graph y equals 6 cosine 2/5 x. So hopefully, remember, this changes your amplitude. Oops. And the 2/5 is your b value that changes your period. It's not your period, but it makes the period something different. So our amplitude is going to be 6. So that means that our graph, I'll scale it in green, goes up to 6, and we'll go down to negative 6. Okay. Now our period is 2 pi over b. So it's 2 pi over 2/5, which is the same as saying 2 pi times 5/2, which is 5 pi. And therefore the interval on the x-axis is your period divided by 4. So that's 5 pi over 4. 3, 4, 5. That'll give us, starting here, so 1, 2, 3, 4, and then 1, 2, 3, 4 will give us our second period. So our interval is 5 pi over 4, so 5 pi over 4. Next one would be 10 pi over 4, which reduces to 5 pi over 2. Then add 5 pi over 4, it's 15 pi over 4. Then 20 pi over 4, which would give us 5 pi. Now that should be one period. Let's check here. It's a positive cosine. Cosine starts up top because at 0, the cosine is 1, and then the amplitude is 6, so that multiplies it by 6. Okay, and then we go to the middle. We go to the bottom at 5 pi over 2. At 15 pi over 4, we're back to the middle. At 5 pi, we're back to the top. Okay, now I'm going to continue to draw a second period here. And this is our 2 periods. Now, I could have also graphed back to the left if I wanted to. All right, bear with me. This is not the easiest Didn't write with, but it's close enough. Okay, it's a curve. I could have also gone back this way. Okay, and I'd want these same values, just negative, and the graph would look something like that. Okay, so let's finish off our tick marks here. So this was 5 pi, which is 20 pi over 4. This is 25 pi over 4. This would be 30 pi over 4, which is 15 pi over 2. 35 pi over 4, and then 40 pi over 4, which is 10 pi. 10 pi is 2 periods, which gives us 5 pi. Okay? Now, what we're going to look at today is when we can start shifting things up and down. Okay? Or left and right. Now, I hope we remember, if we were to graph something like, of course, my graphing calculator is not working here, y equals x squared versus y equals x squared plus 2. Okay? Y equals x squared, parabola, centered at the origin. Y equals x squared plus 2, parabola, shifted up 2. Okay, when you add or subtract a number outside of what your function, this is your parent function, outside your function, that will affect the vertical shift. So if we look at this here, it says, so translations for vertical shifts. This D, okay, which can either be at the beginning or at the end, will affect the vertical shift. Okay, so we'll move it up and down. So look at something like this. So y equals negative 3 plus 5 sine 2 pi over 5 times x. Okay, so our amplitudes. Now, what I suggest doing is writing everything out. So the first thing is our amplitude is 5. That's the first thing we learned. Period is 2 pi over b. So 2 pi over 5, which is 2 pi times 5 over 2 pi, which gives us a period of 5. So our intervals are now the period over 4, which is 5/4. Now this shift is we are going down 3. So now what that means is the axis of our wave, the middle of our graph, is now down 3. So now I will always draw a dotted line through the middle of our graph. Okay? Now from that line, we need to go up and down our amplitude. So our amplitude is 5. So that means our graph is going up to 2 and down 5 to negative 8. From here, nothing changes. Okay, we've got to mark off. I'll just do 1 period, okay, because I'm lazy, but you have to do 2 periods every time. Okay, and our intervals are 5/4. So 5/4, 10/4, which becomes 5 halves, 15/4, and then 20/4, which is 5, putting us at the end of our period. Notice we'll have 5 points. Period was 5, so we're good to go. It is a positive sine graph. So positive sine starts in the middle. Now, normally we'd start on the x-axis, but this shift of negative 3 has moved the graph down. So this dotted line represents the equivalent of our x-axis. So we are here, okay? Positive sine starts by going up, okay? So we will go up, back to the middle, down to our minimum here of negative 8, and back to the middle. And this is 1 period, okay? If you were to graph 2 periods, you would need 4 more points, which would take you out to 10, because 10 would be 2 pi. Okay? Hopefully that makes sense. Next one, 2 minus 3 cosine 1/3 x. All right, so now that's our amplitude. Here our d value again is in the front, but I could also write this like this, and it would be the exact same equation. Okay? So our amplitude is still positive 3. Okay, period is 2 pi over 1/3. Dividing by 1/3 is multiplying by 3. So that's 6 pi. The intervals along the x-axis is going to be 6 pi over 4, which is 3 pi over 2. Okay, and last but not least, now we have a vertical shift going up 2. So the axis of our graph is now up 2. So that's our dotted line, up 2. Okay, the amplitude is 3, so from there we go up 3 to 5, and we'll go down 3 to negative 1. Okay, should actually do that in orange to make it just stick out because it's the labels. No worries. Okay, and now our intervals are 3 pi over 2. So again, you guys should be graphing 2 periods, but I'm just graphing 1. So 3 pi over 2, 6 pi over 2 is going to be 3 pi. 9 pi over 2, 12 pi over 2 puts us at 6 pi, which is what our final period was, so we're good. Okay, it's a negative cosine graph. So let's think, what does a negative cosine graph look like? Cosine normally starts at the top, it starts at a maximum, because on the unit circle at 0 degrees, our cosine is 1. Because it's negative, we are starting down here at the minimum. Okay, and then we go to the middle, we go to the top, back to the middle, to the bottom. Okay, and if you were to continue on, you'd have 4 more points that look like this. Okay, and our cosine graph looks like this. Okay, if you were to continue to label this out, we'd have this final point being 12 pi, because that would be 2 periods. Okay, y equals 4 minus 3 cosine 2x, similar problem. Okay, our amplitude is still 3. Oh, what just happened here? Lost my pen. Amplitude is still 3. Okay, even though it's a negative cosine graph. Period is going to be 2 pi divided by 2, which is just pi. So the intervals are pi over 4. Okay, and we are moving this graph up 4. Okay, it's going to start at a bottom point, same thing. Okay, so you guys can do this on your own if you'd like. I would check it with your graphing calculators and make sure that it looks kind of what it should. Okay, now getting into what the hardest shifts. Okay, are we shifting side to side? Okay, and we shift things side to side when we get numbers inside our parentheses with our sine or cosine. Now notice that we have our b value here factored out. If your b value is not factored out, which we'll probably get to next class, okay, you need to make sure that you factor it out, all right? And then this winds up being your horizontal shift. Okay, it's the same concept. If I look at a parabola for a second, y equals x squared versus y equals x minus 2 squared. This is a normal parabola centered at the origin, vertex of 0, 0. Y equals x minus 2 squared is shifted to the right 2, okay? And it looks something like that, okay? Now notice also, if you hopefully remember, the negative sign is built in. So the graph will shift c units if c is positive, and right c units if c is positive, left c units if c is negative. Okay, now remember, the negative sign is built in. Okay, so this is like x minus a positive 2. So that's why it's going to the right, because c is technically a positive number. Okay, because the negative sign is built into the problem. All right, so y equals negative sine x minus pi over 2. Let's look at what these things represent here. Our amplitude is technically 1, which is nice. The b value is what's in front of your x. We don't have anything, so our period is just 2 pi divided by 1, which is 2 pi, meaning that our intervals are 2 pi over 4, which is pi over 2. Okay? We don't have a vertical shift because there's no plus or minus at the beginning or the end. This is technically a negative 1, which is negative 1 times sine, so that's affecting your amplitude. We are taking this graph and essentially we're shifting it to the right pi over 2 because it is x minus pi over 2. So what that means is that we are starting at pi over 2. Okay? So I'm usually not a big stickler with regards to, like, you know, graph paper and having things being exactly the same with your intervals, as long as we start and finish with what we need. So we're starting right pi over 2. Okay? Our period's 2 pi and our interval is pi over 2. So we need to, would be our first point. We need 4 more points. Okay? So if we continue to add what our interval is, so pi over 2 plus pi over 2 would be pi, then 3 pi over 2, 4 pi over 2, which is 2 pi, and then 5 pi over 2. Okay? The distance from pi over 2 to 5 pi over 2 is 2 pi, which is what our period is. This is a negative sine graph. The amplitude is 1, so it's going up to 1 and down to negative 1. Okay, and now we're just going to point plot. Sine always starts in the middle. Okay, we have no vertical shift, so it's right on the x-axis. It's a negative sign, so instead of starting by going up, it's going to go down. Back to the middle. Oopsie, hold on. I already goofed on this. Great job, Kirkby. Want to make sure you guys were paying attention out there. We're starting at pi over 2, not at 0. So as a result, my first point is right pi over 2, which is right here. And then I'm boom, boom, back to the top, back to the middle. Okay, and this is our negative sine graph. Now, if you wanted to, okay, you could also always graph to the left. Now, if I go from pi over 2 back pi over 2 units, because that's our interval, okay, I could graph it to here, and then this would be negative pi over 2, which would be here, and then this would be negative pi down here, so on and so forth, okay? I'll put that as a dotted line because you don't have to, but just showing you that you could. Now, if you look at this for a second, this looks like it's a positive cosine graph starting at the top with no shift. This is a negative sine graph shifted to the right pi over 2. Okay, this is a very important concept as we continue to move forward here with graphing trig functions. Now, if you continue to graph this and graph 2 full periods, you'd have another point here, 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 and here. Okay, it would look like this. Okay, and technically you would add 2 pi to it. So 2 pi plus 5 over 2 would put us out here at 9 pi over 2. From pi over 2 to 9 pi over 2 is 8 pi over 2, which is 4 pi, which would give us 2 of our periods. Okay? Next one, my apologies, I don't know why this came out as written as pi, but that should be x minus pi. Okay? So now, look at what all these numbers represent. Our amplitude is 3. Our period is 2 pi divided by our b value. Now, our b value is already factored out. It's a number in front of x, which is 4. So 2 pi over 4, which is pi over 2. Intervals, therefore, are pi over 2 over 4, which gives us pi over 8. Okay, this 2 here is moving our graph up 2. And this right here at the end, the x minus pi, is moving it right pi units. Okay, so I'm going to draw like this. Okay, I know we're going up 2 units, so the axis of our wave is now at 2. Amplitude is 3, so we are going to go up 3 and down 3. So we're going down to negative 1, up to 5, and our axis is at 2. And we're shifting it right pi units. So I'm just going to start at pi. Okay, I'm not going to make you guys, label everything in between 0 and pi. Our intervals are pi over 8. So 1, 2, 3, 4. So this is pi, which is the same as saying 8 pi over 8. So the next one's going to be 9 pi over 8, 10 pi over 8, which is 5 pi over 4, 11 pi over 8, and then 12 pi over 8, which is going to be 3 pi over 2. Going from the beginning of our period at pi to 3 pi over 2, that's a distance of pi over 2, which is what our period is. Okay? Positive cosine graph. Now, positive cosine graph starts up top. So at the shift of right pi, we start up top here, go to the middle, bottom, middle, top. That's one period, starting and finishing in the same place. We can play connect the dots, okay, and we're good. Now, if I needed to continue graphing this, okay, I'd have 4 more points. I'd be adding pi over 8 every time. Now, if I went back to the left, and this is where it's going to get a little ugly, if I went back to the left, this is 8 pi over 8. I'd have 7 pi over 8, 6 pi over 8, 5 pi over 8, so on and so forth. So if you like to graph back to the left, make sure you leave yourself plenty of space to fit, because obviously this represents the equivalent of pi units. This is a period of pi over 2 units, okay? But just try to make things as easy as possible on you with you guys with regards to labeling, okay? Last but not least, number 6 here, okay? Notice that we have a plus 2 at the end, so that's the same as the plus 2 in the beginning here. Our amplitude, give myself space, is 3, but it's a negative cosine graph. Now, I have a 2 here that is inside the parentheses, so I need to factor that out. And I'll get x plus pi over 2, okay? I just divided a 2 out, so pi divided by 2 is just pi over 2. My period is going to be 2 pi divided by b, so 2 pi over 2, which is pi. Intervals are the period over 4. So that's pi over 4. Okay, we're shifting it up 2, and we're going left pi over 2 units. So that means we're going to start to the left of the x-axis. So let's do this. Okay, I'm going to start to the left of the x-axis. Okay, we're going up 2 units, so we're going up to 2. That's the axis of my graph, so I'll do that in purple. Sure, why not? My amplitude is 3. So I'm going to go up 3 to 5, down 3 to negative 1. Now, anytime we're going to shift it left, we need to think a little bit here. So I'm going left pi over 2, and my intervals are pi over 4. Hopefully we realize that pi over 4 is half of pi over 2. So this is nice that I have two intervals to the left exactly. So this is negative pi over 2. Okay, this would be negative pi over 4. The next one would be just at 0. Then I'd be at positive pi over 4. Then I'd be at positive pi over 2. That's one period. I'll graph a second one. 2, 3, 4. So this is 2 pi over 4, 3 pi over 4, 4 pi over 4 is 5. As a period, I mean 5 pi over 4. And then 6 pi over 4 is 3 pi over 2. Okay, last but not least, let's play connected dots here with this. So I'll graph it in black. It is a negative cosine graph. So here at our shift, which is left pi over 2, negative cosine starts at the bottom. So here's my first point. Middle, top, middle, bottom, middle, top, middle, bottom. Here are my two periods. Notice I'm starting and finishing in the same place. I have a total of 9 points for 2 periods. Going from negative pi over 2 to 3 pi over 2 is 2 pi, I'm sorry. And my period is pi, so that would be 2 periods. Okay? This can be a little confusing, but I'm sure that we're good because we're smart people. And we'll continue working on this graphing stuff next class.